Hello everyone and welcome to another Java video. In this video, we're going to be solving the greatest common divisor problem. It says that we are to develop a program that calculates the GCD between two integers greater than 0 and determine if the numbers are co-prime. Co-prime means that the GCD between two numbers will be just 1, meaning that we didn't really have a greatest common divisor between them. Okay, so I just wrote a little solution breakdown of if I were to read this problem, what is going through my head to solve this problem. So I would hopefully have learned that in elementary school that the largest possible greatest common divisor between A and B would be the minimum of A and B, because if one number is larger, that can't be a divisor for that smaller number. So the largest possible, if possible, GCD between A and B will be the minimum of A and B. So that makes me use math.min. We're going to initialize greatest common divisor to 1 because we're going to do the following. We're going to analyze all the numbers from 2 to min of A and B all inclusively. And if a factor is found, like if one of those number is a factor to both A and B, then we can update GCD. And the last GCD to be found within this segment of our code should be our greatest common divisor. Now, if with all that, if the GCD is still 1, then the two numbers are going to be declared to be co-prime. So let's get started. We're going to need two numbers, so we're going to do two user inputs. Let's go. So we're going to say system.out.println, enter two values, semicolon right there, and then we're going to go string. We're going to input 1 is equal to sc.next line. That. We're going to have another one of those, input 2, and then we're going to have our num1, which is going to be an integer. It's equal to the following integer, the parse int, input 1. And then we want to do the exact same code, so copy that code, bring it down. We have our user input all done. Okay, now we're going to need to have this like upper limit, right? This is our upper limit of greatest common divisor. So I'm just going to copy this. Right. So we're going to say, we're going to have int upper limit is equal to, using the math.min method, we're going to take num1 and num2. And that's going to be our stopping point for our loop in the future. We're going to have the second point. We're going to have initialize GCD to 1. What I'm doing is I wrote some requirements that I need for my program, and I'm just now translating that to Java code that we know. So that's very simple. We're going to say our GCD is equal to 1. It's been initialized. We're going to be update. It says here, analyze numbers from 2 to min of A and B, which we already have. So that I see that as a numeric analysis. So I want to use for loop. We're going to say int. We're going to say value. We're going to call them divider because we're going to be using to divide. So we're going to set it to divider is equal to 2. We're going to say while divider is less than equal to our upper limit. And our divider is going to go up by 1 every time. So we're going to do divider plus plus. Perfect. We have set up our for loop, right? And then here it says if a factor is found, update to GCD. Okay, that's very simple. It needs to be a factor of both numbers. So we're going to say if num1 modulus the divider is equal to 0, and we're going to do our ampersand here, num2 modulus divider is equal to 0, then we've found that value. So we're going to update to GCD. We're going to say GCD gets updated to our iterating variable that we decided to call divider. Okay, and this for loop is going to go from 2 to the minimum of A and B, and then we're going to have this statement here, right? If the GCD is still 1, then we are co-prime. So we can say here, after that for loop is over, we can say if GCD is still equivalent to 1, we can system.out.println the two numbers are co-prime, semicolon. Otherwise, GCD was updated to something else, so we can say system.out.println the GCD is plus GCD, and we'll end it off like so. Okay, so we had our input section here. We set our upper limit. We initialized our GCD. We used a for loop to analyze numbers from 2 to the minimum of A and B, and for our factor find, we have to use a modulus operator to divide this number by this number, and if that remainder, or that if the remainder of the division is 0, then we know that divider is a factor. And if it's able to divide into both, then we have a common divisor. Therefore, we can update our common divisor variable to this divider value. And the very last one that we find should be the GCD. If it didn't find anything, it'll still stay at 1, so the numbers will be declared co-prime, or we get to output our GCD like that. So let's execute our code. Right, so if we were to say, like, analyze two primes, such as like 5 and 19, right, we can say that the two numbers are co-prime because they really don't share any factors except for 1. But if we give it like values that are non-prime numbers, like 12 and 36, we're going to get that GCD is 12, because 12 itself is a factor of 36. Let's get some other numbers like 5. Let's do 7 and 121. These two numbers are co-prime. Let's try 30 and 32. The greatest common divisor is going to be 2, right? Because we were able to divide these by 2, but we weren't able to get any other values, okay? So that was our program to find a greatest common divisor. This problem is actually very beautiful. That if you do study this problem, there are many solutions that exist out there. This is definitely one of them, but there is a very beautiful problem that's available on the internet called the Euclidean algorithm. So I do recommend that you check that out. Regardless, thank you for watching and stay classy.